Hi, and thanks for tuning in as we walk through Nano X's 3D light scattering. We'll use this filmy clip of a detective as our first example. As we invoke the plugin, you'll see there are two modes of operation, being screen and world space. Screen space mode scatters the highlights on the screen and masks it with the depth map. We'll walk through world space first, which scatters light in 3 dimensions using a 3D model. The first thing you'll notice in world space mode via this yellow message is that we need to render a point cloud to start. So we'll first set the camera motion option to smooth, as there's no camera shake or complex movements here, and click the render button. Once it's done, the plugin switches to the point cloud viewer. This mode is solely to help you visualize the scene, and these colored boxes represent the camera's position throughout the shot. Change the view mode to camera pose and your view mimics the active camera. This is how it reprojects the scattered light into camera space in final composite mode. Moving on to the light scattering group, there are two modes here, called highlight and ambient. Highlight motivation scatters light from the scene's highlights, and ambient fills the scene with a constant color. For this shot, we'll use highlight motivation since we want light to scatter from the lamp. The first thing we need to do is define what light sources will scatter using the light source threshold. Use the Show Light Sources box to visualize which points will be scattered. The light source near limit filters out points that are closer to the camera, in case your subject is bright as the scene highlights. As for the rest of the parameters, density controls the general amount of haze present. Extinction controls the darkening of the scene for a thicker, moody look. Next is air light and halation. Air light is the very wide veil of haze that fills the scene. Halation is the tighter bloom around the highlights. These layer together for a more convincing look. Math mode decides the physical principles that go into the light scattering, me mode being the default. Furthermore, you can adjust saturation and air light color for a funky look. Moving on to air disturbance, which creates textures and patterns in the haze. Strength is self-explanatory, and scale controls the size of the pattern. Then there's the form and motion groups where you tune the look. Turbulence creates pockets in the pattern, filament creates wisps, and vorticity twists it around. Seed angle rotates the starting point, defocus near diffuses it near the camera, and random seed randomizes it. Onto the motion group, flow speed, and direction XYZ control the linear direction that the pattern flows. Vortex rate makes it revolve around the scene center. Vortex center X controls the depth or Z that it revolves around. Evolution controls the rate that it morphs or seethes. Next is the 3D volumetric light group, which casts light waves from light sources. Point source casts from a 3D location, and angular casts linearly in a direction defined by pitch and yaw. In this case, I want to cast a light ray from the overhead lamp. Angular looks fine, but I want it to spread like a cone, so we'll use the point source mode and place the source directly above the lamp. Decay dims the light with distance. Obstruction masks the volumetric light further with depth. Source proximity limit allows you to be selective with which highlights emit rays by limiting them to a radius of the user-defined source. Next, we want to work on the depth estimation, which we skipped earlier, which masks the scattered light from nearer regions. You can see that at first it flickers, so we need to click Stabilize Depth Map. Once it's rendered, we can further filter it temporally using deflicker strength and threshold. Increase strength for the range of the filter, and increase threshold to allow it to filter more data. Increase it too high, and you'll get ghost-like trails. Furthermore, you define the depth levels using near limit and near limit fade, which makes the transition more gradual. Then we have more controls to refine the map. Output to alpha exposes the depth map to the blue output of the node. If you want to use in-depth map from another node, you can switch over to external mode, then structure your node tree this way. Or for a shortcut this way. Skipping virtual light for this example, the last group is Haze Bounds, which filters out haze using a 3D rectangle. A few more tweaks, and here's our end result. This next example we'll go through in Premiere Pro. There are no light sources in this shot, so we'll be using the virtual light here. Per usual, we'll set the camera motion parameter and render the point cloud. The first thing we'll notice is that the chessboard is glowing when it shouldn't. Because we don't want anything in the shot to glow, we'll turn air light and halation off. Then I'll head to the virtual light group, and I'll place it right out of the frame above the subject's heads. Then we'll tune the fall off, then tweak the color and air disturbance for a nicer look. After adjusting the depth map, this is our final look. That's all for today's walkthrough. Thanks a ton for watching, and look out for more updates as we add new features.